Lesson 3 of Module 6, Backup and Monitoring Storage. In addition to providing storage for cloud-based compute services, you can also take advantage of Azure Storage to facilitate backup and recovery of on-premises based applications and data. Regardless of the underlying purpose, Azure Storage also offers fairly extensive monitoring capabilities. All of these features are configurable via both Azure portals and by using Azure PowerShell commandlets. In this lesson, we'll explain how to implement backup and failover solutions for your business and how to facilitate monitoring of the underlying storage that serves as the foundation of these solutions. More specifically, in this lesson, we'll cover storage monitoring and implementation of Azure backups. Monitoring can be set in both the Preview portal and the Management portal. Monitoring and diagnostics are disabled by default, but can be easily enabled and configured once a storage account is created. You can configure different levels of monitoring separately for blobs, tables, and queues within the same storage account. The monitoring can be set to either minimal or verbose, or it can be turned off. If you turn off monitoring, existing monitoring data is persisted through the end of the retention period. Note that this is the default setting for each storage type. The retention policy period can range from 1 to 365 days for each storage type. The minimal level allows you to collect basic metrics such as ingress and egress storage traffic, availability, or latency, all of which are aggregated for the blob, table, and queue storage services. Verbose monitoring collects metrics for each storage operation in the Azure Storage Service API. Verbose metrics allow for in-depth analysis of storage access and performance issues. Note that using verbose monitoring for a long period of time will incur a cost because monitoring data is stored in the same storage account in a set of tables, including $metrics transactions blob, $metrics transactions table, $metrics transactions queue, and $metrics capacity blob. Once you have enabled monitoring for a storage account, data should start to appear in the portal user interface within about an hour. In the Management portal, monitoring statistics are displayed in charts on the dashboard and monitor pages for that storage account. The full set of metrics is available on the monitor page. You can also configure alerts for the metrics displayed in the portal. An alert is associated with an arbitrarily chosen counter and allows you to send an email notification if that counter exceeds a threshold you define. In addition to monitoring, you can also generate logs for each of the storage types in your storage account. These are diagnostic logs that record read, write, and delete operations. You can use these logs to examine storage operations in detail, as well as diagnose poor performance or investigate malicious attacks. Logs are held by default in an Azure blob at http accountname.blob.core.windows.net/$logs. You can view its content by using any of the tools or methods we presented in the previous lesson. When enabling logging for a storage account, you need to specify the types of events that you want to record, such as read requests, write requests, or delete requests, as well as the retention period in days. In this demonstration, we'll show you how to configure monitoring and logging and how to view operational events. In this demo, we'll use Azure Preview portal to enable diagnostics on the storage account we created in the previous demo. To start, from the interface of the portal, I'll click Browse, then scroll down to storage accounts in the Browse blade. Then click the storage account we created previously in the storage accounts blade. I'll maximize the storage account blade. Click total requests today tile in the monitoring section of the blade, and this should display diagnostics blade. I'll click on to change the status and then select each one of the checkboxes within that blade. Leave the default retention days, click save, and wait for the change to take effect. After a relatively short wait, you should be able to see the diagnostics being collected and the metric data being displayed within the preview portal. And this completes our demo. In Azure Recovery Services, you can use site recovery to replicate and fail over from one on-premises set of virtual machines to another. Alternatively, you can replicate and fail over to a set of virtual machines hosted in Azure. You can also use Azure Backup Vaults to protect data by using Azure as an off-site backup storage. Configuring site recovery is a complex task that requires a significant amount of planning, particularly for on-premises to on-premises scenarios, which involve System Center Virtual Machine Manager. In particular, you need to plan the System Center VMM infrastructure. For example, you must set up the on-premises VMM clouds, and for on-premises to on-premises failover that includes the Hyper-V clusters, you need to set up the Hyper-V replica broker role. You need to also create an Azure Site Recovery Vault. In the Azure Management Portal, when you create a vault, Azure generates a registration key, which the site recovery provider will use to authenticate. Next, you need to deploy the Azure Site Recovery Provider. This provider is a key component that you must install on every VMM server. In addition, you need to deploy the Azure Site Recovery Services agent to every Hyper-V host server that runs virtual machines that you want to protect. Another requirement involves network mappings. This way, you ensure that virtual machines don't lose connectivity to each other and to clients after a failover. You also need to configure storage mappings, which designate the location where virtual machine disks are stored. Finally, you must enable protection for virtual machines. As far as backup vaults are concerned, you can use them to protect server data by using automated backups to Azure. The maximum retention time for production data using Azure Backup is at this point 3,360 days, which is over 9 years. And the maximum size of a single backup from a specific volume is 850 gigabytes. If you wish to retain data for longer than 9 years, you can use System Center Data Protection Manager combined with Azure Backup, which at the time of recording of this presentation allows customers to return their data for up to 99 years. In addition to Windows Backup, you can also manage your backups by using Windows Server Essentials and System Center Data Protection Manager. To implement Azure Backups, you must complete a number of steps, including creating a backup vault in the Azure Management Portal, downloading a vault credential, downloading and installing a backup agent, configuring the backup agent to use the vault credential, and registering the server with Azure Backup, and finally configuring a backup job in the management tool of your choice on the protected server. In this lesson, you learned how to monitor and diagnose storage, as well as how to implement Azure Backup. As part of our review, will answer a single question related to storage and will provide some best practices regarding Azure storage services. The question is, why should you collocate storage accounts and the Azure services that use them? And the answer is collocating storage accounts and applications that use them in the same data center will significantly reduce latency when transferring data between storage and services. It will also reduce cost by minimizing charges for data transfer out of the data center. As far as the Azure Storage best services are concerned, you should make sure to choose the most appropriate storage type based on your application requirements and the format of the data to be stored. You should also collocate storage accounts and the services that use them in the same region or affinity group. And finally, when storing blobs, use block blobs for large objects that you want to either upload or stream, and use page blobs when the application access patterns are random.